So day 2, part 1, starting with geometric sequences. So geometric sequences are basically what you were doing yesterday when you were looking at exponential functions. These are patterns that are multiplying. Okay, so if you look at all 3 of these on top, each of them is a geometric sequence. They're all doing the same thing. And I know that seems weird because you have some fractions here, you have some numbers that are growing, and some numbers that are getting smaller, okay? But each of them is multiplying. So I think the most difficult part for this is trying to find the pattern when it's not obvious. So if we take a look at the middle one. I think the middle one is the one that's the most obvious to recognize the multiplier, or they call it the common ratio. Common ratio is the number that is being multiplied to get to each step, to the next number, okay? So also, if you're having trouble finding that number, what you can do is take the second number and divide it by the first number, and that'll give you the common ratio. Or you can go to the last number and divide it by the number before that. Now, they will both give you the same answer. 12 divided by 3 is 4. 192 divided by 48 is also 4, which means these are multiplying by 4. And you can test it with this one too. You can do 48 divided by 12, or you can just do 12 times 4 gives you 48, and that's your common ratio, okay? So that's one way to find the common ratio if you can't see it, if it's not obvious. Now here, I know most people will say this is dividing, but it's not. In a geometric sequence, they are still multiplying. So what you can do again, take the second number, divide it by the first one. Okay, now you can do this as a decimal, but I'm going to leave it as a fraction. If you simplify that, you get 1/2. So what that means is this is multiplying by 1/2. So one thing that you should know is if you're multiplying by a number that's smaller than 1, it's going to be decreasing. But notice we're not multiplying by negatives, so we're not multiplying by negatives here. You can multiply by a negative, but a negative doesn't necessarily make it go smaller, okay? When you multiply it by a fraction or a decimal, that's when your numbers get smaller. If you're multiplying by a whole number, it's going to get bigger, okay? Now, I guess if I gave you a simple formula for this, to look for the common ratio, we'll call it the R. To find the common ratio, take the second term and divide it by the first term. Now, in this problem, your second term would be 6. Your first term would be 4. You could divide that and get a decimal, or we could just simplify it as a fraction and you get 3/2. So what that means is happening, this is multiplying by 3/2. And if you turn it into a decimal, that would be 1/2. So this one is getting bigger, but you're not multiplying it by just a decimal or a fraction, because this number is 1/2. So that is bigger than the number 1. It's going to get bigger. It's just not going to get as big as this one's going to get. That's multiplying by 4. Okay, so that's the way you find the common ratio, or I call it the multiplier. Okay, so let's take a look at this one. Formulas. You need to know that number to make a formula. So if you take a look at this, we have a sequence, right? Now it's getting bigger, but it's not obvious. The number that it's dividing by is not an obvious number. So we're going to use the formula I just gave you to find the common ratio, which is take the second term divided by the first term. So we'll take 36 and divide it by 27. Okay. So again, you can turn it into a fraction, a decimal, but I like fractions for this because especially if the number has a fraction, I'm going to stick with a fraction. If it had a decimal here, I would write it as a decimal. But these both divide by 9, so I get 4/3. So my multiplier is 4/3. Okay, so that's important. The other thing you need to write down is your starting point or your first term. What is the first term you have? 27? That's number one, A1, okay? And actually, those are the only two things you need for your formula. So if I was going to write the explicit formula for this, and this is the one we use the most often, I would write this: AN equals 27 times 4/3 n minus 1. And this is my favorite formula because right now you have what terms? You have you have 1, 2, 3, 4, and 5. You have the 5 terms. You have 5 terms in the sequence. Let's say you want to get to the 10th term, right? Let's say you want to go all the way down and you want to find the 10th term, right? Well, you can keep multiplying it 1, 2, 3, 4, 5 more times. You can keep going down, or you can just use the formula, okay? So if you use the formula, if you want to find the 10th term, A10, all you do is you take this formula and plug in 10 for n, okay? So what happens if you do that? Well, if we do that, we're going to end up with 10 minus 1 is 9, so you have 27 4/3 to the 9th power, okay? So I'm going to show you how to use Desmos to solve this, so I'm going to go to my calculator. And like I said, I like this calculator, guys, because you can type it exactly as you see it. So I'm going to go 27, parentheses, fraction, 4/3. Oh, sorry, I already messed up. I don't want parentheses there. Sorry about that, guys. I want here, parentheses here. But actually, I want an exponent there. I need the exponent right there, right? So what exponent am I going to take this to? And the 9th power. To the 9th power. Now, there you see the answer as a decimal. But this box will also convert that to a fraction. So you hit this, there's your answer. So if I wanted to find the 10th term, I get 262,144 all over 729. So that would be my answer. That would be the 10th term. Now, of course, I'm not going to ask you to do something this crazy, but the calculator makes this possible. Just by plugging in whatever one you want. If I wanted to find the 100th term, I plug in 100, and I'm good. Just with the first number and the common ratio, okay? Now, the recursive is different. The recursive only needs one number. What was the common ratio? 4/3. And that's it. I know, right? This one seems really easy. And it is, because it only does one thing. This formula only lets you find the next one in the sequence. Like, I couldn't plug in 10 the way I plugged in 10 here. In this problem, the last term they gave me was the 5th term. This was term number 5. So I could use this to find the next term, A6. So if I wanted to find A6, it's not a problem. But that's the only one it could find. It could only find the next one. So I put this in here. Now again, what's going to be 6 minus 1? That's going to be 5. So what are we doing? How are we going to find the 6th term? You're going to take the common ratio, 4/3, and multiply it by 85 1/3. This was the 5th term. This was term number 5. So this is how you do it. So again, you would use a calculator, right? So let me get the calculator out. Let me clear this. Okay, so I do a fraction, 4/3. Again, so I should use a different mouse for this. Let me try that. Different mouse. 4/3 times 85. I want it at the end. I want it here. How do I? Sorry, I should have figured this out before. I'm trying to combine this together. 1/4 third. There you go. And then you know what? I'm going to turn it into a fraction. So there it is. There's my next fraction. So A6 is 1024 over 9. So you could simplify that, I guess. Divide that by 9. I know what we get. 124 over 9. 124 over 9. Yeah, 113. Will it give it to me as a fraction? Nope, keeps it like that. You can leave it like this. I would say 113 and the fraction here, which is probably 7/9. 113 and 7/9. But this calculator doesn't tell you that. Well, there's one limitation right there. But yeah, that's what it does. It helps you find just the next term. So this one's limiting. The recursive formula is very limiting. But if all I want is the formula, that's all you need to do with it. And if all I want is the explicit formula, this is all you do with it. These steps is how you use it. And in all honesty, you should just use this one. Just use this one instead of using the recursive. Whatever term you're looking for, all you do is plug in the one you want. What do you want to plug in for n? Plug it in for n. The first thing you do is subtract 1, and then just put that in your calculator. And that's how you work with sequences.